All right. Hello. Welcome to our next lesson. Our last one was on exponential growth. And for exponential growth, instead of our typical exponential equation looking like this, our exponential equation looked like this, where we were given a percent growth, like 15%. But in order to find our multiplier, we had to change it to a decimal and add it to 1 to get our multiplier inside. So again, if we had 15% growth or 15% increasing, we take that 15%, change it into a decimal, and add it to 1. And that becomes our multiplier for our exponential equations. So one example that we had, I believe this was on the mastery check, was which of the following could be used to represent this equation? So right away, looking at this, I see increased or decreased. That's the first thing I need to figure out. So the fact that this number, my multiplier, is bigger than 1 tells me that it's an increase. Again, when our multiplier is greater than 1, our numbers are going to grow. When my numbers are getting smaller, my multiplier is less than 1. So here it's bigger than 1, so it's an increase. So we can get rid of C and B. So now it comes down to, well, what was my percent increase? Was it 25% or 125%? Well, remember, to get our multiplier, we did 1 plus our rate as a decimal. So to go backwards, we're going to take that 1 away. And now we're at 0.25 is my rate as a decimal, and we have to move that decimal place back over. So it was 25%. So again, when given a problem like this, state whether it's increase or decrease based on whether this number is greater than 1 or less than 1. And if it's greater than 1, you need to take the 1 away, move that decimal back over to get your percent. Now today is all about exponential decay. So when I tell you something is decreasing, getting smaller, another word that we like to use that you'll see quite often is depreciate. And again, that just means it's losing value over time. So for exponential decay, as x increase, my y is decreasing. So as we go through time, that y value is getting smaller and smaller and smaller. For a growth, my multiplier, that b value, was greater than 1. So for a decay, it has to be smaller than 1 or less than 1. So when we have a multiplier of 1/2 or 0.21, both of those are less than 1, which tells us that this is a decay. My numbers are shrinking. Now the difference, the key difference here is that for a decay, when we are decreasing by a percentage, we are going to subtract it from 1 to create our multiplier. So that's the key difference here. So our new exponential equation that we learned on Tuesday was 1 plus r to the x. What we're learning today is that it can be plus or minus depending on if it's an increase or decrease. So you're going to have to read your story problems and determine, is this an increase or decrease, and choose the right way to find your multiplier. So again, if I told you something was shrinking by 25%, that means for b, we're doing 1 minus 0.25, and my multiplier would be 0.75. So my final equation would look like this. A 0.75 to the x. So let's go ahead and just practice that for a second. So we're taking this and we're doing 1 minus our rate as a decimal. So I'm going to change it to a decimal first. once, twice. And we do 1 minus 0.09 instead of plus. Ooh, whoops, not that. 0.91. Again, move that decimal twice. 0.75. This is a decrease, so 1 minus 0.75. Dollar minus 3/4 is 1/4. And once, twice, fill it in with a 0. So this one would be 1 minus 0.009. Oh man, my brain is in a funk. Yes, I'm using a calculator. Don't judge. There we go. Okay, 0.991. Sometimes my brain doesn't work either, y'all. Okay, so 1 minus that to give us our multiplier. So again, that's what's going in for B. We would plug that into the parentheses, the 1 minus 0.09, to get what that multiplier is. So go ahead and try these 6. You're changing it into a decimal. 1 minus your rate as a decimal to get your multiplier, and then come back when you're ready. All right. So there are your answers. Give yourself some stars if you got them right. So again, move that decimal place twice. 0.2. 1 minus 0.2 is 0.8. 1 minus 0.95 is 0.05. And so on. If you need longer to look at these, go ahead and pause me to fix your answers or check out how you did. But for now, we're going to move on down to this next problem here. So we have every year from the time a car is new until it becomes old enough to become a classic, the value of the car decreases or depreciates. Most cars depreciate at a rate of 24% per year. So that means whatever your car is worth, it's going down 24% of that value. And then the following year, it's losing 24% of that value again. So cars actually depreciate fairly quickly, which is pretty sad. So how much does a car depreciate every year? So a car depreciates 24% every year. And how do we turn that into a growth factor? Again, it's just what we did up here. So 1 minus our 0.24. So for creating our equation for part C, his truck costed $25,000. And to find our multiplier, we do 1 minus 0.24. So my final equation is going to look like that. That is the equation I'm going to use. So again, this says it is decreasing, depreciating, which gives me 1 minus, and then my rate as a decimal. So 1 minus my rate as a decimal, we plug that in for our multiplier, and we can simplify that to get our actual multiplier, 0.76. Okay, now again, this is a decay. If this said most cars increase at a rate of 24, then it would have been 1 plus 0.24. So it's very important to pay attention to the words in these exponential problems from now on, because it's going to tell you whether you're doing 1 minus your R or 1 plus your R. And now we can just create our typical table. So it says, with 0 representing your first year, which is 2011, make it to 2015. So 2011, 2012, 2013, 2014, 2015. And then again, for our tables, we start with that initial value. And very beginning, time 0, when we brought that truck off the lot, it was $25,000. Zoom in. And then again, my multiplier now is 0.76. So I'm going to take that 25,000 and times it by 0.76. Ooh-wee. And then whatever I get, I'll times that by 0.76 and then times that by 0.76 all the way down until we fill out that table. All right, so 25,000 times 0.76, which is my multiplier. We get 19,000. So already after 1 year, your car is worth $6,000 less than what it was. 0.76. Now we're down to 14,440 times 0.76. 10,974. And then last one times 0.76, 8,340. All right, so again, to turn it into a growth factor, 1 minus our rate, that is our multiplier. We can simplify that to get our actual B value. To create your table, start at your initial value, use your multiplier. Now these decay functions tend to look like the letter L. So my car started at a cost way up here, and it's slowly losing value. Or not so much slowly, but it's losing its value over time. So we're starting way up here at 25,000 and then losing our value. Now, you can see that it starts to flatten out and it's not as steep. That's because 24% of 25,000 is a lot larger than 24% of 10,000. And that's why 25 jumps down to $19,000, $6,000. Again, because 24% is a bigger chunk of 25 versus 24% of almost 11,000 is only $2,000, $3,000. So over time, the amount that we're losing is getting smaller because how much my car is worth is smaller, which is why it starts to flatten out here. But this is our typical look for a decay. Remember, for our growth, when we said an increase of 24, we see something instead that looks like this, that rockets up towards the sky. That was our increase. Okay, now we say, what was the estimated truck worth in 2017? So I know I'm going to use my equation that I've created. So 25,000.76. Now we started in 2011. So 11, 12, 13, 14, 15, 16, 17. So this is 6 years later. And then now again, I'm going to do 0.76 exponent to the 6th year, and we times that by our initial value. And we get 4,817. Ay. So that means after 6 years of having your car, it's only going to be worth 4,800 bucks. Wild. Cars depreciate so fast. Okay, so a couple things. Again, for your calculator, make sure you're in scientific mode. Decrease, which is 1, 2, 3, and 4. You're looking at 1 minus your R value. The first one, you are going to have to create your equation. So you're looking to do your A value, 1 minus your R as a decimal. And then give me what your final equation would look like. This one, you need to figure out what was the percent before this. So do 1 minus 0.86, and then change that to a percent. This one down here is a growth, so be careful. Message me when you're done.